Teams. There we go. All right. Yeah. Good afternoon. And what we need to do is, we need to pick up a little bit on where we left off because the Thursday holiday in our timetable really put a kind of wrinkle in the time schedule. And so, I'll say this again at the end, but you're going to see that there are 2 special sessions next week for us. Sorry about that, but we need to march along here. I got a great picture back in the 60s. There we are. We need to march along here and keep on trucking it. We need to get back in step and keep in sync across everybody and all of the groups. And the best way to do that is to suck it up next week and get a couple of extra things in because, there's another holiday on Thursday, first week of November. So we're going to make up those 2 sessions next week Tuesday, next week Wednesday. And again, I realize that's a real squeeze for some people, starting as soon as something else is ending or ending is just at the same time something else is starting. But it's the only space in the schedule. It does the same thing for me, to tell you the truth. But it's better we get it out of the way now, all right, and stick with the program so that a little bit, it gets a lot more relaxed in the second half of the semester. And ouch, man, we don't even know what the timetables are going to look like in the second half of the semester at this point. So that's why we're going to make that happen next week. Be busy as little bees next week. And after that, get back to our smooth cruise, let casual lifestyle. All right. So what we want to do today is just go back and review a little bit of operating systems theory. All right. And we kind of almost got a little ahead of ourselves this morning when we said we assume that you have this part done. So we need to right now just go back and double check that we understand what we're doing in that part. And then next week, we need to do a quick review on networking, all right? And again, things that you should know from a previous class in networking, all right? And we'll actually end up introducing a new topic on Wednesday, all right? Again, half of it, I'm sure you're familiar, at least basically, with what DNS does, all right? But DHCP is usually just a bit of a mystery because nobody messes with it until they have to, all right? But that's where we'll be next Wednesday, so that Thursday when we go in, we're all going to be right in sync, all right? And ready to clone off our 2-clone virtual machine, create the other servers that we need, and get started getting them configured. I can't say it enough. The recipe for success, yeah, DHCP server automatically applies IP addresses. Good on you, man. Good on you. Don't worry about it. You've already invested the time and effort to understand some of these things. Good for you, all right? But we're keeping the pace for the people who have not had that opportunity, that motivation, all right? And so that's why it's so important for us, yeah, to move together as a group, all right, for the first half of the class, first part of the semester. After the semester break, we loosen up. We've got a lot more, shall we say, latitude for creativity and following your interests in your specialization. Okay, so let's just review some of the operating systems concepts that are important to this first part, all right? This first part, by what I mean there is, in a second, I need to do a reload on this so the menu works right, is the creating VMs part here, all right? Now, this is in Moodle. No, it's not. Stop doing that. There we are. All right. This is the one in Moodle. When we looked at this morning, we passed this by. We said, yeah, all right, we're going to assume that you know this part. All right. Assume that you have this done. The 2 clone 1 and the 2 clone 2. All right. That's a video presentation. It must be about 8 minutes or something like that. A video that is exactly the same as this PDF here. All right. This PDF goes screenshot by screenshot. Actually, the first two things. But those two videos go screenshot by screenshot like this. All right. And so either way, we need to end up at this point where we have this 2 clone server up and running and properly configured. Okay. The boot order right, how to get the CD-ROM drive in, the base ISO. All right. Get the network card set up, host-only adapter. All right. Start it up. Get to the login screen. And all right, this is the point between 2 clone 1 and 2 clone 2. All right, 2 clone 1 is just the VirtualBox menus and the virtual machine BIOS settings. 2 clone 2, what, is where we get a little bit technical. Because the first thing we need to do is partition the disk, all right? And again, there are complicated command line commands to do this, all right? But we pick it off the menu and, 2 terabytes, ouch, man, we need 200 megabytes. So there's plenty of things that are plenty of options, all right? But basically, it's really simple. You just say create a new partition in the free space, make it 200 megabytes, automatically comes up partition type Linux, make it bootable, all right, get the little star up there, then move down to the free space, save that one or create that one for virtual memory. All right, that means we need to change the partition type to Linux swap. It's a little bit old school, but because, you know, new times people try to use a swap file rather than a swap partition. But again, a technical detail that we don't really need to worry about in the normal circumstances. This is just a very necessary step for our system. But we just pick it off the menu and write it down to our virtual disk, ready to save. Just choose write. You have to type YES here because it's all paranoid. If you're doing this on something that already has data on it, it can be a little bit hazardous. All right? You've got to be very careful if you're repartitioning a disk that already has data on it. But ouch, man, VirtualBox, we're creating them. They're absolutely blank, factory fresh. So all we need to do is just YES there. And then once we're finished, quit. We need to lay down a file system. We've got some PowerPoint. That's what we want to talk about. We want to talk about the disk partition, the file system. What's the difference between a file system and a partition? And the next step, using MC, our favorite Linux file manager. We talked about that this morning, yeah? All right. To install the operating system. And installing the operating system is as simple as copying a few directories across from the CD-ROM drive to the virtual hard drive. And the very last step, again, one that we need to understand a little bit in theory, all right? Final step, to install the bootloader. That's what actually makes this a bootable hard drive, all right? If you get a message that says, cannot boot, no operating system installed, it means you messed up this step, okay? So in order to avoid that, the problem here is that there's a hard disk side. Hard disk side looks like this. CD-ROM side looks like this. And they both have one called boot. All right, so you need to be, and it's not about the left side, the right side. You got to look at the top up here and know where you are at. You need to be on this side, all right, and then go into this boot, and then find this one and highlight it and hit enter. All right, it's a green star one. You know what that means from this morning. That means it's executable, all right? And this one will install the bootloader into the master boot record. And if that sounds mysterious, I'll show you what it looks like in theory in the PowerPoint in a couple of minutes. But once you get that part done, then you're ready to start on the next steps that we talked about this morning. I know we're getting a little bit backward here, but ouch, man, just because of the timing. And that makes it so much more important for us to suck it up next week and get those 2 extra little hours in, right, in order to get back into and in with the program here. All right? But again, it's automated for us. All right. And down here at the end, a few more steps to configure common services. That's what we talked about this morning. All right. Again, it's because of the Thursday holiday that we're a little bit upside down. So we'll correct that next week. Swap partitions, ain't it supposed to be done by default? Okay. Okay, let me just answer this one right here. Swap is virtual memory. You can see it in Windows if you look up Windows virtual memory, all right? But more common is swap file, all right? And you can find it in your Windows file system. Just Google it up, it's not a big deal, all right? But unpredictable size. And that is, yep, page file. Because technically, I can hear, technically, memory is allocated in pages. Whatever that means. Let's not go there. All right. The names are enough, and the number of names is enough. But the idea of virtual memory is that if you run out of RAM, it's the operating system swaps it down. But the real point is that it is rarely actually used by the operating system, but right? So here's the thing. Again, our operating systems all work the same, and they're all based on the 70s and 80s model. And it's because people, I don't know, they're very proud of their heritage. They're very afraid to change something that works. I don't know. But anyway, with gigabytes of RAM in place, it is extremely rare that the operating system takes advantage of virtual memory. And that's the case for more than 10 years now. But when we're setting it up, when we're installing it, the operating system expects it to be there. If it's missing, then it's going to complain, and in most cases, it will automatically create something. All right. We're a little bit old school. We use an operating system. We use a virtual memory. We make a partition on the hard disk for virtual memory rather than using a swap file. All right. There's really no difference except the swap file takes up disk space in our file system and it can get corrupted. The Partition is just there on the disk. We just set up the swap file system on the partition, all right? And the operating system takes care of it. It's totally invisible to us, all right? So it's just a setup step, just an initialization step when you install the operating system, all right? And so that's all it's for. It doesn't get used. We don't have to think about it after we get everything set up, okay? So, yeah. Let's PowerPoint a little bit, and let me back this off a little bit here so that I can. Yeah, well, and that's because it's a file, yeah. Most, if not all, OS. It's not done, it's done automatically, invisibly. We just do it explicitly for this one. But the point is, it's never used anyway. And so, you know, never mind. All right, let me back that off a little bit more. So we got some smooth transitions here. Okay. Let's zoom through this part kind of real quick. All right. Some of it we saw this morning. All right. And yeah, let's go through it. Let's go through it kind of in order here. All right. Basic block diagram of an operating system. Again, you should have seen this in another class sometime before now. All right. The operating system is the layer of software between the users and their applications and the low-level firmware, device driver software, and the hardware itself. The operating system kernel interfaces with the CPU, the memory chips, the devices, all of the things on the motherboard, all right? And we try to stay outside of that, all right? This, for people doing the degree, I know, and people doing diploma, I think, all right? You got an operating system class where it was talking about process scheduling and queuing, algorithms, and all of this stuff that MQA says it's important for us to understand, all right? All of this low-level operating system stuff, we try to stay out of here as much as possible. It's important for us to know that it's here and that it exists, but if we can ignore it, we will, all right? Let the operating system take care of itself. This line here that's called system call interface is a boundary line that we like to call user space and kernel space, all right? Up here in user space, this is where we live, and we use whatever facilities are provided by the operating system to check out this part, all right? We saw a little bit of that today, all right? System call interface, up above that part is task manager, which gives us a view into the process control subsystem of Windows. All right, so we're going to stay up here, but we need to know that this is going on. All right, device drivers, all right, 70 or 80% of an operating system installation is device drivers for all kinds of devices that are current and legacy, all right? Keyboards, USBs, audio cards, video cards, screens, whatever we have, there's got to be a device driver for it before it's going to work, right? And this concept of the file subsystem is one that we'll get into later because it's a lovely concept. We can have a lot of fun with it, all right? But just the point here is we've got to have the right device drivers for our hardware, all right? And the idea of processes time sliced by the operating system scheduler, and the concept of a service has a different name in Linux, all right? I don't know what they call, I don't know even how to say that, daemon or daemon. I think it's daemon, but and I don't know why they call it that. But, you know, never mind. We've got to be proud of our heritage, and that's where that word comes from. Now, all of this complication, especially with the process control subsystem here, all right, means that we need to be careful about shutdown. Always shut down properly. Just one more time, right? Just like this. You got power here and shutdown. All right, we've got to do that for our virtual machines as well, because Linux is as complex and real an operating system as Windows. But taking care of all of this cleaning up, that's what shutdown does. Other thing, again, check your power settings. Never hibernate. Only sleep, all right? Because if you have a VM running and your system goes to hibernate, write it off. It's dead, okay? It goes to hibernate with a VM is running. It's that VM is just not going to work anymore, all right? Sleep, never mind. You can leave them sleeping. If your processor goes to sleep and you have VMs running, you can come back 2 days later and everything's in good order. I tried it. Permissions, again, we talked about this morning. We're a little upside down here. What? Every process, every system resource has one owner. Properly, every owner belongs to a group, and everybody else that is on the system is the rest of the world. Right? Now, again, we looked at this interface this morning. All right. The thing is, for every process is there, and every process has a PID and a status and a owner, all right, user or a group, all right. Services are a special class of process. Every service is a process, but not every process is a service, all right. And services can be registered but stopped or running. And again, we talked about how we get services on the startup list so that services start running at boot up. All right. This morning, when we were changing the permissions on those scripts in etc rc.d. File permissions, all right, that's the way we see them, all right? We see them as file permissions, disk D, all right, or any file. We see that's the way we access them, but actually they apply to all kinds of resources on our systems, right? In case you're curious about what the Windows permissions are, they're listed here, right? Just for your information and breadth of understanding. Linux permissions are, this is what they look like in MC. MC is the best way to do this, all right? Read, write, execute, all right? Comes out to 755. These three up here, only used for special purposes. Special directory permissions, this is the one for var run, all right? Var run, make sure you do this one right, all right? Don't go into var run up here. Make sure it just says var run is highlighted, then F9, and fill in those two blank ones, all right? To set the sticky bit and world writable. This is one very special case, all right? There are a few times when we need to do this in a whole system configuration. Normally, it's something that never gets up in our face, all right? But when we're setting up our services, this is just one of those small things that we need to be able to manage and take account of. Control and do wonders like a demon. Yeah, ouch, Matt, your explanation is as good as mine on that one. Otherwise, check Wikipedia. But please don't tell me I have more important things to think about. Let's talk about a more important thing here. What's a disk partition? All right. Now, this is just a stylized view of a disk. All right. It does represent more or less a CD-ROM drive, but it has no relationship at all to the actual hardware of a USB drive or an SSD. But being proud of our legacy and really, you know, kind of still feeling nostalgic for the 70s and the 80s, right? The SSD has what they call firmware to emulate this, all right? And again, it goes to this whole legacy technology thing. The guys made the new hardware and said, yeah, mate, this is great. This is really new. It's really cool. It's totally different. And the operating system people said, no, 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 no. We do not want to change. And so the hardware engineers scratched their heads and, you know, maybe said some bad things about the other guys. But what they did was they made a new layer of software so that their cool technology emulates this old school 1974 style technology. What? So we don't really know the difference. The operating system guys didn't have to change any of their tools. They put all the pain on the engineers of the new technology. So never mind, it's all done for us. All right. Hey, microphone off, please. Yeah, thanks. Okay, so when we do the partitions, we've got two partitions, one for data and one for swap. Again, I've done this on my hard disk here. You might have it on yours as well. Oops. All right. I've only got actually one physical disk in this machine, but I've got 3 partitions here. All right, this one is supposed to be for a Linux dual boot, but it hasn't gotten there yet. Another one is for all kinds of code and Python and things, and the other one is the Windows partition that if something, some kind of malicious virus or something comes along and wipes it out, I don't really care because, you know, it's just Windows. Everything else important, I keep on the other ones. All right. But what's the difference between a file system and a partition? All right. Partition is very close to the hardware, and it's actually maintained in a space on the hard disk, you come down here, called the master boot record. All right. And the master boot record is the part that is read by the BIOS actually before the operating system starts. Because when we have different partitions, we can have a different operating system on each partition. Actually, I just mentioned that. All right. My drive, local disk E here is still blank. All right, because the intention is to have Linux installed on this partition so that I can pull up a menu when I turn on the computer and pick if I want to boot Windows off drive C or if I want to boot Linux off this partition on the hard disk. That's what's called the master boot record. And in the master boot record, there's a table that says, okay, if you pick Windows, then jump to the boot record for this one, right? If you pick Linux off the menu, jump to the boot record for this one, and use the information that's stored there to start the operating system, right? When we create a swap partition, again, same thing happens, all right? When the operating system gets started, it knows that there's a particular space on the disk that's reserved for virtual memory. But that's the same thing when we create a page file. It's just a certain space on the disk that's already allocated. The operating system feels free to use for its own purposes, all right? Whether we call it a file or whether we call it a partition, the only difference is we call it a partition, it's recorded here, all right? When we call it a file, the operating system keeps track of it all by itself. Just to skip up here, as long as we're talking about partitions, all right? The IPL, the BIOS IPL, ooh, don't you love the acronyms? Yummy, alphabet soup. IPL, the initial program loader, all right? Part of the read-only memory on the motherboard, all right? Loads the master boot record, all right? Using the firmware in the motherboard and on the drive itself, all right? And it reads the master boot record to select the active partition and loads up the IPL for the operating system from there, all right? That's where we're going to see a process that has a very low number, like 0 or 2 or maybe as much as 6, all right? That's called init, all right? Actually, when we look back up here, we do it this way. System interrupts, there it is. We got a PID 0, system idle process. System process is 4. all right? In Linux, it's called init, all right? We'll be able to see it with a number, again, like 2 or 4 or 6 or something like that, all right? And that's the whole thing that starts off the boot process to give us access to our computer, all right? And oops, the whole thing moves on from there, all right? And until we get to a process, this is probably going to be anywhere between 250 to 750, all right? The initial logon processes, and from there start new processes as we start up our desktop and our apps and things like that. Oops, ouch, no, what happened there? Okay. One last component is the file system, okay? The file system is how the operating system keeps track of what is in the storage, all right? It's an abstraction. It doesn't match up directly to the storage units that are actually managed by the firmware on the drive itself, all right? It's a logical abstraction that the operating system uses to store the data. And again, the device drivers are there to mediate this levels of abstraction between the operating system and the actual electronics and the media on the drive itself. Okay? So there's different file systems for different operating systems and for different purposes. Right? Usually, if you put a average USB onto your computer and go down and look at the properties, I'm not going to do it on this one, it gets messed up. But if I look at this, just right click on it and properties, all right? It says my file system is NTFS and tells me the free space. All right, never mind. Let me plug this one in. All right. There's a USB drive that I just plugged in. Let's see what it says on properties. Oh, this one is NTFS. Average ones are usually FAT32. All right. But the thing is, FAT32 has maximum file size 4 gig. All right. So it's good for small ones, but if you want to store, you know, big virtual machine images that can be 3 or 4 or 5 or 6 gigabytes all by themselves on a USB drive, you know, 32 gig for a removable one, or your terabyte external hard drive, all right? That's when we need NTFS, because, you know, there's a gigabyte, there's a terabyte, and then there's an exabyte. And so it's an order of magnitude higher. Right? But FAT32 is still common on USB drives on the Windows side. On the Linux side, ext3, I don't know why that one's here. Nobody ever used ext3. ext4 is the most common one, all right? It's basically very similar to NTFS. ext2 was the other one that everybody used for the longest time. And again, basically comparable to a FAT32. in terms of the things that define file systems. Now you have more than you know, more than you need to. Amuse your friends. You know what? ext4 for Linux, NTFS or FAT32. That's the part to know for the exam. Oh, and now we're right back to where we started. This is ancient old advice. Ouch, man. That's very 80s. I should take it out. But sometimes, you know, somehow we're proud of our heritage and it's part of our environment to be that way. Okay, so by this time next, all need to have 2 VM set up and configured like first things first. All right, here's my typing gun. Okay, so there's our mission. All right. If you do that, you're going to be right on track, all right, for the rest of the semester. Okay. And again, we've got a little bit of extra time set aside next week to make up on the backgrounds and things, but we need to keep moving forward and keeping in sync, all right, to get a really successful outcome from our class here, all right? So, if you have any problems, use team chat, all right? Bring it up in the meeting chat, all right? But we want to make sure we get this done because we all want to have